Hi, I am Bhavik Thakkar. Welcome to Betitude. If you're more comfortable with Hindi language, please hit the I button and watch the Hindi version of exact same video. But if you are comfortable with English, let's carry on. Well, in this particular video, we have come up with the third challenge question. The question I've taken from the chapter and topic of Alligation and Mixture. So you can actually pause the video, right? And you can answer the question on your own first. Just give it a try. It's a very good question, and this kind of the questions are asked in the recent examinations. So that's why I've come up with this particular question. What I'll be doing is I'll not be only solving this question, I'll be giving you all the concepts related to the topic Alligation and Mixture so that you can answer this question and you can understand the logic behind it so that you can answer the other questions related to the same topic as well. Alright then, before actually we start this particular question or solving this particular question, let me give you a brief about the whole structure of this particular video. So first of all, we'll try to understand the alligation and mixture concept, but then we are not only going to use this particular question using that particular concept. Of course, that is what the Betitude method is all about, but at the same time, we'll also understand how you can solve this question by equation or by option by any means. Because when you know how to solve a particular question with different methods, you are conceptually better, right? So let's start with the concept of alligation and mixture, how we can use it to solve this particular question. But before that, let's understand the concept in itself, all right? So the alligation mixture is the concept which actually gives us the idea when two different varieties are mixed, right? And average of those two different varieties are given and the combined average is also given. And if we are supposed to find out the quantities in which those two varieties are taken, we use the shortcut of alligation and mixture. For example, just try to understand this. If I've got certain varieties of say sugar worth rupees 30 a kg, and if the other variety is 50 rupees a kg, if I'm mixing them both, fine. So here the average is average price, right? The average price of this cost, this particular mixture or this particular quality is 30 rupees a kg, the other one is costing 50 rupees a kg, and if I'm mixing them both and the combined cost comes as say for example 45 rupees a kg, and if the question is, so when we are given all the three averages, right, when you're mixing two mixtures, so independent or individual average is given and the combined average is also given, and when we are supposed to find out the quantities of each or the ratio of quantities of each, we can use alligation mixture, which says the difference between these two, that is 5, goes to the other side, and the difference between these two, that is 15, goes to the other side. That makes it 1:3. So we can actually say that the quantities are mixed in the ratio of 1:3. Fair enough. Now there is a logic behind it as well, but I am right now not going into it, fine, because it is outside the scope of this video. Fine, that I've already explained in some basic videos, fine, that why we are doing this, because that's the Betitude thing. We always explain you why exactly we are doing something, fine, because when you know the reason, it's easier for you to understand and memorize it. All right then, so once you know this, you can actually use that same thing in this particular question as well, fine. Let's try to understand how we can answer this question. This question can easily be answered within a minute, fine. We'll try to understand. Now, first thing, many students will think, sir, let's solve this question by option, right? Many students think, and they think, okay, so the total mixture is in the ratio of 13:4. Now, I don't know where, but they know or they think that means the total mixture is in the table of 17. And that is what exactly we are asked, right? We are asked the total initial quantity. So they'll say the multiple of 17, there is only 168, and that's our answer. That's not your answer, right? That's not your answer. So it's not always easy to go by the options. That is first thing. And also don't follow the methods which don't make sense. I don't know why somebody is teaching like this. Fine, just go by option and just, you know, pick 17 stable. There is one, it's your answer, that's it, go to the next. It's not the case because you didn't read the whole question. If you would have read the whole question, you would understand that 27.5 liters is actually taken out. So that means when you remove 27.5 liters, now that number is also not a fraction, right? It's going to be a fraction rather. So it's not going to be in the table of 17 either way, right? So now that's why it's not always easier to go by an option. Yes, of course you can go by an option, fine. It would take more time because you would think, okay, if it is 53 liters, 27.5 liters is taken out. Now how much is remaining? Then divide it in the ratio of 13:4. Then add those two things. Then check whether it is 25% water or not. So if it's not the case, you will have to choose the other option. That could be a method, nothing against it. For example, if I am going with 53 liters, I would say if 53 liter was there, this is already taken, that means 25.5 liter is remaining now. And in that, milk and water are in the ratio of 13:4. So divide these into 13:4, you will get 19.5 and 6, right? You will get this if you are good with your basic calculations. And then you will think, now I am adding 2.5 liters of water, so plus 2.5 and 5 liters of milk. So now it is becoming 24.5 and 8.5. Now in this, is water 20%? If this is 1/3 of this, because 1/4 of total, that means 1/3 of this, then it is the correct option. If it is not, you will have to choose the another option. So you can go by option, but it's going to kill your time, as you saw that, right? So it's not always the best of the methods, but you should know how to go about it. Now you can pick up the another option, follow the same method. If this is 1/3 of this, that means it is 1/4 of total, that is 25%. It's your correct answer. Fair enough, right? Let's move forward to the next method. So option is not the best method to solve this kind of a question. Then which one it could be? Let's try the equation method. So look, again, equation is not the best of the methods to solve this kind of a question, but we must be knowing it. All right. So now let's try to understand here. So it is 13:4. So total liters we don't know, right? We start with like X is the total liters. Now, of course, we'll say 27.5 liter is added. Now water was how much? 4/17 of this, right? So we'll say 4/17 of X was the water. Now water is added. How much water is added? 2.5 liters. So this is going to be your new water. The water before plus whatever you have added, this is the new water. Now new water is 25%, that means 1/4, but of what? Of the new mixture, right? So new mixture would be, so whatever your original mixture was X plus minus 27.5. First thing, try to understand, minus 27.5. Now here there is a problem. This X is total, right? 4/17 of it I can understand, but then 27.5 liter is even removed. Now here there is a catch. Look, if you don't understand the catch, then it would be lengthier. So let me make you understand of that particular logic in the Betitude method, because normally you don't know the logic. So here actually you should have removed that milk part as well. So which would be, we forgot, right? We forgot here. We should have removed 4/17 of 27.5 liters as well, because this is total. But obviously 27.5 liter is removed, out of which 4/17 would be water as well. Fine. So you have to actually do 4/17 of X minus 27.5, right? This would have been a proper equation. So 4/7, because there was total liter was X minus 27.5, because 4/17 is common for both of them. So water was this much plus 2.5, and now the total liter actually is X minus 27.5, but now you have added 2.5 plus 5, that is 7.5. So you can solve this, something like this. But of course, it's going to kill our time as well, right? It's not going to be that easy. Fine. First of all, you can also make a mistake here. Fine. Like X minus 27.5 was necessary. And then X minus 27.5 plus 7.5 is your total mixture now. Making sense, right? Again, we are not going to solve this particular question like this, but just to make you understand, just so that you are conceptually better, I explain this one to you as well. So we are going to use, of course, the Betitude method. Now what we understand in Betitude method is, okay, so if in a mixture, this is 1/3 of water, right? Whatever quantity is taken out, in the remaining, how much is water? Again, it's going to be 1/3 because I am not able to separate water and milk, right? I am still going to just pick up randomly. So it is thoroughly mixed. So 1/3 of water will still be there. Are you getting it? So if that's 100 liters, in which 1/3 is water, if I am taking half of it, in the remaining half, still there is 1/3 water, right? So considering this catch, if you understand this catch, it becomes easier because you can easily understand here that whatever the quantity was, forget about it. In the remaining quantity, we don't know how much it is, but still the ratio would be this. That means water would be 4/17, right? Right? Now what we are adding? This and this. So how much is the water in this new mixture? 1/3, right? 2.5 out of 7.5. So 1/3. And when we are mixing, water becomes what? 1/4, right? Fair enough. Now you should be able to find out fast because you know the bases are different. So you cannot calculate directly, but you can make the denominator same, like 4 into 3, 12 into 4. So it becomes 48 here. 17 into 4, 68 into 1. This one becomes 68 here. And 17 into 3, 51 into 1. This one becomes 51 here. Fine. So the base are same now. What I did was I made the base 17 into 3 into 4. Are you getting this? I'm not calculating the LCM. It has to be 17 into 3 into 4. So now the base is 17 into 3 into 4 in all three, right? But the numbers are easier and I don't have to write down the common denominator because it's going to be common in all three of them. So how did I do it? Just try to understand. 17 into 3, 51 into 1, that becomes 51. So denominator, because there is already 4 is there. So I have to multiply it by 17 and 3. Here I have to multiply, because 17 is there, I have to multiply it by 3 and 4. So 3 into 4, 12 into 4, 48, right? Once I know this, it's easy. The difference of these two and these two. This 2 is 17, this 2 is 3. That means these two quantities has to be mixed in this ratio 17:3. And we know that this particular quantity, the second one in which 1/3 was water, that particular quantity is 7.5 liters. So now I can say if 3 is 7.5, how much is 17? And if you are good enough, you know it is into 2.5, right? 3 into 2.5. So 17 into 2, 34 plus 8.5, 42.5. So that means 42.5 liters of initial quantity is taken to mix. But you already took out 27.5 liters. So if you add them back, so initially there has to be 70 liters, right? Are you getting this? Fine. You can go back and forth, understand the concept. And now I'm going to give you an idea. If in exam you have done enough practice, how much time it will take to solve this particular question. Let me remove this, erase this particular data. And then we will understand how exactly quickly we can answer this particular question. So once you will be reading, you will understand, okay, this is the one, this is taken out. So it's still the same. This is added and the water is given. So let's take the water. 4/17, 2.5 by 7.5 is 1/3. Finally, it is 1/4. 12 into 4, 48, 68 and 51. So that means 17 is to 3, 3 is 7.5. So 17 has to be 34 plus 8.5, 42.5. But 27.5 was already removed, which makes it 70 liters. That's it. Less than a minute. If you time it, it has to be less than a minute. Fine. And that's what you should be actually taking to solve this kind of the question in the examination. Fair enough, right? So I hope you enjoyed this one. And I've got a home assignment for you. So it's kind of the same kind of a question. Fine. Please pause the video. Try to answer it on your own. And once you get the answer, please put it in the WhatsApp group. Fine. Or maybe just a comment in the YouTube videos comment. Just put it there. Fine. That is very important, because when you are putting the comments, I'll be knowing that, you know, people are not only watching, they're also solving it. Fine. And if possible, put all the methods as well, like how you arrived at the answer. Fine. So I hope you enjoyed this one. And yeah, if you enjoyed it, you can, you know, ask your own questions as well. You can ask your question in the same YouTube comments, or you can actually go to join our WhatsApp group where the students ask the doubts, or you can go to the Telegram channel of Btitude. The description of the same is given in the description of the video. Fine. Alright then, keep watching, keep learning and keep enjoying.